In this video, let us discuss about how at minimum deviation the angle of incidence comes equal to angle of emergence. For that, let us consider a prism like this, a triangular prism. Let's consider a point P in here, and if I draw an incident ray at the point P, it will get refracted like this. Okay, before that, let me draw the normal at the point P. This will be the normal. See, normal is always perpendicular to the surface. Let's name this point T. This point be U and this one be V. So the normal, this N dash, will be perpendicular to TU. So this is the angle of incidence, I1. Let's take that as I1. So when light travels from, see, this is rarer medium, this is denser, this again is a rarer medium. So when light travels from rarer to denser medium, it bends towards the normal, like this. Okay. Now, at this point, let's take that as point Q. The light is moving from denser to rarer medium. So, before that, this is the angle of refraction R1 at the first surface. This is the angle of incidence and this is the angle of refraction. And now, the light has to move from denser to rarer medium. So, I again have to draw a normal. So, this is the angle of incidence at the second surface. So, we can call that as R2. R2 means the angle of incidence at the second surface. And finally, the ray will move like this. Clear? And this angle will be the angle of emergence. Let's name that as I2. And in the last video, we already derived the expression for deviation delta, that is deviation delta is actually angle of incidence plus angle of emergence minus angle of the prism. This is the angle of the prism. We already derived this expression. You can always go back and check that video, the previous video. Okay. Also, we have the expression for the angle of prism as R1 plus R2. Okay. Let's put this as equation number 1 and this as equation number 2. We also derived this expression. Okay. Now, what we need to find is, here I1 must be equal to I2 at minimum deviation. That's what we have to prove in this derivation. It's actually a lengthy derivation. So listen every point, every section very carefully. Okay. Before that, deviation actually means this is the path of the incident ray. This should be the way incident ray must be going. And this is the path of the emergent ray. Deviation means this angle, delta. Clear? This is the deviation. Can you see this? This is delta. Okay. That is the angle between the path of the incident ray and path of the emergent ray. So first what I am doing is, I am differentiating this equation. Differentiating equation 1 with respect to, let's take I1. That is, I1 is the angle of incidence. So what I will get, d by di1 of this delta angle of deviation. You have to differentiate on the left hand side and on the right hand side. That will be d by di1 of this whole term, I1 plus I2 minus A. This will be equal to, left side you can write d delta by di1 is equal to di1 by di1 plus d by di1 of I2 minus d by di1 of A. Okay, so this will be d delta by di1 is equal to, this becomes 1 plus di2 by di1. Clear? And at minimum deviation, we have, by the rules of derivatives, d delta by di1 must be equal to 0. Clear? di1 must be 0. Therefore, 1 plus di2 by di1 equal to 0 implies di2 by di1 equal to, taking this one to the right, it will become minus 1. Okay, so this is the first equation, the third equation. Let's consider as equation number 3. Okay, now we have let's take this equation, that is the second equation. Derive this equation also, that is differentiate equation 2 also with respect to, let's take I1 again, differentiate with I1 again. So what you get, d by di1 of A is equal to d by di1 of R1 plus R2. So this becomes, see, or you just write dA by di1 is equal to, this will become dR1 by di1 plus dR2 by di1. Clear? But this angle of prism doesn't change. So this will become 0. The differential of a derivative of a constant is 0. So 0 is equal to dR1 by di1 plus dR2 divided by di1. Implies, taking this term to the left, you will get minus dR1 by di1 is equal to dR2 divided by di1. Simplifying this, you will get, take this dR1 to the right, or you can cancel this one. Then you will get dR1 by dR2 is equal to minus 1. Okay, or you can take dR2 by dR1 equal to minus 1. Either way it is correct. So let's take this as equation number 4. Clear? Now we have the refractive index of the prism. We can apply Snell's law at P, that is applying Snell's law at the point P. You can write sine of angle of incidence sine I1 by sine of angle of refraction sine R1 is equal to refractive index mu. Here if it is air, we can take the refractive index of air as 1 and absolute refractive index of air as 1 and the absolute refractive index of the prism as mu. Here also it is air. Clear? Which implies, or let's take that as such for now. Now applying Snell's law at point Q, applying Snell's law at Q, you can write, this time the angle of incidence is R2. So sine R2 by sine of angle of incidence, sine angle of refraction, here it is angle of emergence, I2. See, for this surface, R2 is the angle of incidence and I2 is the angle of refraction. But I2 is also the angle of emergence. So sine R2 by sine I2 equal to, this time the ray is moving from denser to rarer. So we always have to consider the second medium first. So it will be 1 by mu. We already discussed about this in the previous video. If you have any doubt, you can go back and check that video. So taking the reciprocal on both sides, you will get sine I2 by sine R2 is equal to mu. Okay, so these two equations on the right hand side, it is mu. So I can write, the left hand sides must be equal. So sine I1 by sine R1 will be equal to sine I2 by sine R2. Clear? Now let me cross multiply this equation. And I'll get sine I1, taking this to the left, sine I1 into sine R2 is equal to sine R1 into sine I2. Clear? Let's call this as equation number 5. Okay. Now again, let me take that refractive index. Applying Snell's law at P, we have sine I1 by sine R1 is equal to mu. As we this thing we just write it before. Okay, the Snell's law at the point P. Now I have sine I1 is equal to mu into sine R1. Now let me differentiate this equation on both sides with respect to I. That is d by di of sine I1 is equal to d by di I1. Sorry, this is I1 of mu sine R1. Okay. So the derivative of sine is cos. So cos I1 is equal to, see, this is equal to, you can take the mu out. So mu into derivative of sine R is cos R1 into, see here the variable is different. You are differentiating R1 with respect to I1. So you have to put dR1 by dI1. Clear? Let's take that as equation number, let's say equation number 6. Clear? Again, let me write this equation here. That is cos I1 is equal to mu cos R1 into dR1 by dI1. Okay, that's our equation number 6. Now, when you take the Snell's law at the second phase, that is at TV, we have sine R2 by sine I2 is equal to 1 by mu. We just took this before. Okay, the same case. Now if you take the mu to the left, you will get sine I2, that is 1 into sine I2 is sine I2, equal to mu sine R2. Now differentiate this also, this equation with respect to di1. So d by di1 of sine I2 will be equal to d by di1 of mu sine R2. So that will become, this is derivative of sine is cos I2. Here the variable is different. It is I2. We are differentiating I2 with I1. So I have to write di2 by di1 is equal to, here mu will come out. Derivative of sine is cos R2. Again the derivative different, variable is different. So dr2 by di1. Clear? Let's consider this as equation number 7. Clear? Now let me divide. Let me erase this picture. Now if you divide this equation 6 with equation 7, that is equation 6 divided by equation 7, what you get? First divide the left hand side. So it will be cos I1 by cos I2 into di2 by di1 equal to, on the right hand side it is mu cos R1 dr1 by di1 divided by mu cos R2 into dr2 divided by di1. Clearly, if you look at this term di2 by di1, we know di2 by di1 is minus 1. So this will become minus 1. So cos I1 divided by cos I2 times minus 1, this is minus 1, equal to, you can cancel this mu. Also this di will get removed. And dr1 by dr2, if you look at here, that is minus 1. So on the right hand side it is cos R1 by cos R2 into minus 1. Clear? And if you take this minus to the right, minus 1 into minus 1 become plus. So I can remove this minus 1. See, minus 1 into minus 1 is plus. So I can remove this negative sign. And if you cross multiply, you will get, take this to the left. So cos I1 cos R2 equal to cos R1 cos I2. Clear? Let's call that as equation number 8. Clear? Now let me erase all this. Now let me subtract equation 8. Let me subtract equation 5 from 8. That is equation 8 minus 5. What you get? On the left hand side it is cos I1 cos R2 minus sin I1 sin R2 equal to cos R1 cos I2 minus sin R1 sin I2. Clear? See, this is cos A cos B minus sin A sin B. That is actually, this is cos A cos B minus sin A sin B. A here it is I1 and B here it is, B here is R2. So this will become cos I1 plus R2. See, cos A plus B is actually cos A cos B minus sin A sin B. Here also it is cos R1 plus I2. Clear? When cos A equal to cos B, you can write A equal to B. So you can remove this cos. So I1 plus R2 is equal to R1 plus I2. So you'll get, let me write it here, R2 minus R1 equal to I2 minus I1. Call this as equation number 9. Clear? Now what I am doing is I am just adding equation 8 and 5. Okay. And if you add equation 8 and 5, that is equation 8 plus equation 5, what you get? So cos I1 cos R2 plus sin I1 sin R2 will be equal to cos R1 cos I2 plus sin R1 sin I2. You add the left hand side and the right hand side. Okay. So this is the expansion of cos of I1 minus R2. Here it will be cos of I2 minus R1. Clear? So here also you can remove the cos. So I1 minus R2 is equal to I2 minus R1, implies if you take the R to the right, it will be I1 minus I2 is equal to R2 minus R1. Clear? This is equation number 10. Now I can equate equation number 9 and equation number 10 because we have R2 minus R1 as the common. So I1 minus I2 will be equal to I2 minus I1. Clear? So if I take I1 to the left, so I1 plus I1 is equal to I2 plus I2, that is 2I1 equal to 2I2, implies cancel this 2, I1 equal to I2. So that's the reason why at minimum deviation we have angle of incidence equal to angle of emergence. Clear?